Here we have a matrix of 3 real-time NXP microcontrollers. So what this is doing is controlling the motors on the crane frame itself. This is talking over Ethernet to this single board computer with an IMX8 equipped on it. That is driving a QT application. That is ingesting a feed coming from the camera. We're running facial recognition on that. So what we can do is tie a face to some account. We can then sign into an account by just looking into the camera and logging in. Once we're logged in, we can then use the microphone to issue Alexa-style commands to control the crane. So really, we're showcasing the broad spectrum of software that we can work on here. So we do everything from microcontroller firmware up to Linux applications on more serious applications processors.
But we forget that historical data reflects where society has come from and isn't necessarily where society wants to go to in the next step. So it's about making sure that the data that we are using to validate and to form these systems is representative of actually where we want to be rather than where we've come from.
Now, introducing a second microcontroller onto the board had some challenges. So primarily that's coordination between 2 different microcontrollers you've now got on the board. One of the problems with that is your communication protocol. So because your communications are going off one chip across the PCB onto another chip, you've increased the chance of data corruption. So in this case, it was really important that we had a transport protocol with error detection, which in our case was a CRC. The consequences of if you get a message where the CRC indicates an error is now you've got to design your system to be robust to a message possibly getting lost between the 2 devices.
Hi, I'm Mark Winton, working from the Avnet Silica Microsoft team. Here we're introducing Windows on ARM. Witekio has helped building the BSP for it. And you're actually seeing the full-blown Windows 10 IoT Enterprise running on an ARM 64-bit processor. Something completely new. And Avnet here has the Smart Module, which is the IMX8M. So we're actually the first ones in the world to have a fully working industrial platform where Windows is running on it.
So my name's Matthew Clavey from Thermal Vision Research, and we're a partner with Teledyne FLIR, and we sell infrared cameras predominantly aimed at the science market. So on the stand today, and in fact yesterday, we have the FLIR camera over here, which is the X6900. So that's the world's fastest thermal imaging camera at 1,000 frames per second.
Hi, I'm Andy Halstead from Silicon Labs. I'm here today to demonstrate one of our flagship AIML products. It's called the MG24, and really what we're doing here is demonstrating what is possible right at the edge on a couple of dollars device. It's basically taking an image and it's superimposing on it what it thinks are people, and by virtue of that then kind of counting this.